Let's begin. Today's December 18th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 6, 11, 18, 19, 20, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our middle digit, the square digit, and the Turing machine will let us know whether it's an even digit or an odd digit. Criteria card B will take a look at our first 2 digits, triangle and square, and compare them. So should the value of triangle be less than square? Should they be equal? Or should the value of triangle be greater than square? Criteria card C will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D, again, takes a look at our first 2 digits, triangle and square, but this time it'll add them up and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E will take a look at our 3-digit solution, but it'll tell us a little bit about its structure, so to speak. Specifically, it can inform us that all the digits there are no repetitions in our solution, as in the example 1, 2, 5, or it could tell us that it may be a double number where there is a single digit repeated, as in the example 1, 1, 2, or it could even be a triple number, a single digit repeated 3 times, as in the example 2, 2, 2. And finally, criteria card F, again, we'll take a look at our 3 digits from triangle to square to circle, but this time it'll let us know a little bit about the ordering of the digits. Should the digits appear in an ascending order, meaning that they are increasing, as in the example 1, 3, 5, or could it be a descending order, as in the example 4, 2, 1, or could our 3-digit code have no order? Let's take a look at the example of 2, 3, 1. Notice it goes from 2 to 3, it increases, and then it goes from 3 to 1, then decreasing. Obviously, you could have a solution that's decreasing and then increasing, but basically it's that shift from one direction to the other that can define a 3-digit code as having no order. Now, we have seen in other puzzles where there is an additional case of no order, and that is when you have consecutive equal digits. For example, 1, 1, 2 is such a case. Notice that the ones are equal and consecutive. They're next to each other. And the reason they exhibit no order is because when you go from 1 to 1, that doesn't show any increase or decrease. And so that's what I meant, that consecutive equal digits are another case that exhibit no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card A. Okay, so the Turing machine does not approve of my choice. I did pick an odd 1 for square, but since the Turing machine does not approve of that, it's actually informing us that square should actually be even. Well, let's go ahead and type that up in our notes in section C. And we'll say that square is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds. So crossing out 1, 3, and 5. The next thing I think I'd like to test is criteria card C. Okay, so the Turing machine does approve of my proposal. Notice we are adding up all the 3 digits, And so if I add up 3 and 1, that gives me 4, and 4 plus 4 is 8. That sum total is even, and the Turing Machine approves of that. So let's go ahead and type that up in our notes in section C. Oops, I meant to write this in A. So let me do this. Let me just say, hey, this is A, and then I'll make the adjustment in C, put it in A, and we'll say that triangle plus square plus circle should be an even quantity. And what can we say about that? Well, and again, let me write a note here saying that, hey, this is actually C. Okay. Well, it's not liking that. Let me give it a couple of spaces. Let's see if it accepts that. All right, fantastic. There we go. All right, so if we take into account what we learned from originally criteria card A, that middle digit is even, and if we want the sum total to be even, then we have two scenarios. Either both triangle and circle are both odd or both even, because regardless of which case that is, whenever you add two like values, meaning either both odd or both even, that sum total thus far would be even, and of course then we'd be adding up our square value that is even. Okay, so yeah, we're looking either for an odd even odd solution or an all even solution. Now I will say that based on previous puzzles, if you've watched any of the previous videos, we've been able to deduce criteria cards E and F. And the argument goes as follows. If we presume that the 3-digit solution is in ascending order, meaning that they are increasing, well, that means that all 3 digits must be unique. There shouldn't be any consecutive equal digits. So they are uniquely increasing. So again, that would mean that they would be all different, which is what criteria card E would be testing. And so we would know if it's ascending, there should be no repetitions, making criteria card E in that case irrelevant. And similarly, if you had a descending solution, again, it's just in the opposite direction. They are uniquely decreasing. And again, that would imply that all digits would be unique. And again, making criteria card E irrelevant. And we can't have that. So that means we can safely deduce that the solution, we'll say we're going to deduce that the solution has no order. Okay. And we can make a somewhat similar argument taking into account criteria card E. If you had a triple number, basically as the example 222, if you had a triple number, that would imply no order because all the digits are equal. There is no increase or decrease from going from one digit to the other. So if you had a triple number, you'd know there'd be no order. So making this criteria card F irrelevant. If you had a double number, notice again, you have that consecutive equal digit setup for the solution, regardless if it's the first two or the last two. There is no change, as mentioned, between those first two digits or last two. Now you could also have a code where, say, the middle digit separates the pair. Well, that would be, increasing and then decreasing. Again, another example of no order. So again, making criteria card F irrelevant. So that means that we can safely deduce criteria card E and state that the solution should have no repetitions. So we'll deduce that the solution has no repetitions. Okay, and so having no repetitions means that you cannot have three evens. So in fact, triangle and circle must be odd. And again, the reason is if there are to be no repetitions, those two evens, well, if you had a 2 and a 4 and it's an all even, you would have to duplicate one of them, and we can't have that. So yeah, so that means that triangle and circle must be odd. So let's go ahead and cross out the 2 and the 4 in both triangle and circle. So we are looking then at an odd, even, odd solution. So typically I would reserve the deduction of E and F when I see it until when we're discussing how to construct a second proposal, but I thought it was quite relevant in order to state that, yeah, we're looking at an odd, even, odd solution. And so we know that the sum cannot be equal to 6, because in order to get a sum that's equal to 6, you would need to have digits of the same type. For example, 1, 5 are both odd, or 2, 4 both even. So in this case, we know we can't have a sum of 6, so it really does come down to being either less than 6 or greater than 6. Similarly, for criteria card B, we know that since we're dealing with an odd and even digits, respectively, or in some order. Oh no, yeah, it's odd even. You can't have equal digits. So I think, I think it's a toss-up, honestly. So let's go ahead and we'll just test criteria card D. Okay, so it is not the case that the sum of the first two digits is less than 6, right? Because in my case, I've got a 3 in triangle and a 1 in square. That sum is 4. 4 is less than 6, but the Turing machine does not approve of it. We've already stated that the sum cannot be equal to 6. So we're going to deduce that the sum of the first two digits must be actually greater than 6. So let's go ahead and type that up in our notes in D. And we'll say, we're going to say that we're going to deduce that the sum of triangle plus square must actually be greater than 6. And so what does that mean if the sum is to be greater than 6? Well, in order for the sum to be greater than 6, I don't think triangle could be a 1, because a 1 plus a 4 is just 5, not greater than 6, so we can eliminate it. And I think that might be all, because you can add 3 and 4 and 5 plus any of those digits. Okay, so that sum of 6, that's it. What else? I think that might be it. I don't think we can cross out anything else. Yeah. Okay. Well, that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So it looks like I think everything else is well established. The only thing we did not test is criteria card B. I think that's what it all boils down to, is what could be resolved to. We already created and made all these other deductions. So let's go ahead and take a look at our solution here. So we know we got to have a sum that is greater than 6. So we know that if it's going to if there's going to be a 3, that would mean that it would have to be a 4 because 3 plus 2 is 5. So it would be 3, 4, and because of no order and no repetitions, it would be 3, 4, 1. So let's go ahead and start maybe typing some of these possible answers. And so it looks like 3, 4, 1 might be the only possibility with triangle 3. So what about 5? Well, it doesn't seem like it could be 5, 4, because then how would you pick between 1 and 3? Those seem to produce ambiguous solutions, and in addition, they'd all be descending anyway. So yeah, I don't think it could be 5, 4. So it looks like it would have to be 5, 2. And then it would be 5, 2, 3. And I think that's what it comes down to, essentially. And so let's see, would criteria card B resolve that? Well, in the first case, it looks like triangle is less than square. And in the second case, it looks like triangle is greater than square. So yeah, it looks like choosing one or the other should be sufficient to figure that out. So let's go ahead then and just pick one. I'll just say 3, 4, 1. And just to cover, or just to review, that middle digit is even. It is. Criteria card A, the sum is even. Yeah, it's a sum of 8. The first 2 digits do add up to be greater than 6. There are no repetitions, and it has no order. It increases and decreases. So it's going to be a quick second round, and so let's just go ahead and test B. Okay, so it is not true that triangle should be less than square. So in this case, we'll be able to deduce, and again, we know that they're not equal, and we know that triangle should not be less than, so it should be true that triangle should be greater than square. So triangle should be greater than square. And of course, the only one that meets that criteria is 5, 2, 3. So let's go ahead and cross out this potential solution. And so yeah, so 5, 2, 3. So let's go ahead and cross out the 3 there. Cross out the 4 here. And then, of course, it was 5, 2, 3 because of the no repetitions. So we can cross out the 5 in circle. And again, that's 5, 2, 3. So let's go ahead and type that up. And let's go verify that that is indeed the solution. So 5, 2, 3. 5, 2, 3. Fantastic. Well, how did we do versus the Turing machine? Well, it is a 6 criteria card puzzle, but we only had to do 4 tests. We outright deduced E and F. And in the first round, we did A, C, D, with C being the only correct one. And then we did B in the second round. So let's go ahead and type that up. So that was A, C, D. Again, C was the only correct one, and B was also incorrect, and we outright deduced E and F. Well, fantastic. So we beat the Turing machine by 2 questions. We did it in 2 rounds, only 4 questions. The Turing machine did it in a complete 2 rounds for a total of 3 tests. Well, again, all the glory should go to being able to recall this deduction I've definitely used it in many puzzles, so it's becoming second nature. Again, the only difference is when do I reveal it. I don't tend to reveal it at the beginning, especially if you're a first-time watcher. It may be a little overwhelming, but I do tend to reserve it till the second phase. But in this case, I thought it was very pertinent into establishing that it should be an odd, even, odd solution, because I knew there were going to be no repetitions. Well, what about you? How did you solve it? Had you seen videos before and recalled how criteria cards E and F in this case, establishing the repetition versus the order? Do you remember that combination? And did you use it? Or did you discover something else in your choice of criteria cards and proposals? Something that I'd like to call aha moments. Did you notice anything special that you'd like to share? Please do add those in the comments. If you did like the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.